Hello, my name is Lauren, and I'm going to be talking to you today about what's new in Reach and Devices and Android Vitals. I'll be joined by my colleague Ben, who works with some of the most successful developers on Play. I want to start with a reminder of why Reach and Devices and Android Vitals exist. Reach and Devices gives you context for foundational business and technical decisions, like what device specs to build for, where to launch, and what to test. We launched it because the Android ecosystem is complex and fast-moving, which makes it challenging for developers to make these decisions today. Android Vitals helps you track and troubleshoot technical issues in your game once they hit real users. Quality is critical for success on Play, and Vitals is one of our most established products. Together, you can use these products to build better experiences for more players and to ground your game investments in a strong business case. Today, I'm going to talk about new features that we hope will delight many of you and dramatically improve your workflows. I'll start with Reach and Devices, which is where you'd also be starting if you were developing a game from scratch. Reach and Devices gives you user and issue metrics across a number of key dimensions like SoC, RAM, and Android version, down to country level. You can see peer data alongside your own app data, and if you are in the Google Play Partner Program, you'll have heard that you also get Play-wide device distributions as well. This all sounds like a lot of data. I mentioned that Reach and Devices is a decision-making tool. How do you actually make decisions with it? To answer this question, I'm going to hand over to Ben.
Thanks, Lauren. Hi, everyone. I'm Ben. I'm a developer relations engineer on Android DevRel Games. As Lauren mentioned, some of the most frequent questions we hear from game developers are, what devices should we build for? Where are players having issues? And how can we improve our game's reach? Now, these have traditionally been challenging questions to answer. The Android ecosystem is a big place with a lot of diversity. But Reach and Devices has a lot of data to help you out. And I'm here today to show you a few practical examples of how you can use it to make informed technical decisions. So let's start with the first question. What devices should we build for? And this pops up the most when starting development on a new title. You want to figure out a set of minimum device requirements that will allow you to achieve the grand vision for your game, but you still want it to run well on as many devices as possible. One of the major metrics to consider first is memory. High fidelity games take up a lot of it, and a game's memory budget has a huge influence on the quality of the game assets and the rendering techniques used. Running out of memory is a common problem we see with game developers all over the world, and they're continuously asking us for more information on device memory. So I'm happy to report that with Reach and Devices, you can finally and easily view detailed memory information. This is a screenshot of the RAM overview page. Let me explain what's going on. What you see here is the distribution of device memory across the active Android devices that have my game installed on it. The blue bar represents my game's install base on devices with an available memory amount that falls within that specific range. So according to this chart, about 28% of my active players are using a device with 3 to 4 gigabytes of RAM. Now, here is where things get interesting. You can select a specific game genre to analyze against, and it will show up as an orange bar on these charts. In this example, I've picked the shooter genre. That means that the orange bar represents the median distribution for an anonymous set of top shooter games. Looking at the first bucket, I can now see that about 36% of top shooters are being played on devices with 3 to 4 gigabytes of RAM. So let's say I'm trying to figure out what my memory budget should be for a new game I'm developing. It's a shooter, so I've selected that genre for my peer data. And I'm interested in LATAM, so I'm only going to be looking at active devices in Brazil. My initial Minspec is 2 gigabytes of RAM, but I'd like to see if it's worth the engineering effort to try and reduce it in order to reach more users. I know that real-world devices usually have many other apps that are also running and might be taking up memory. So it might be a stretch to achieve unless I make significant asset, rendering, and gameplay changes. Now, looking at the orange peer data, I see that 28% of Brazilian players across the top shooter games are only using devices with 1.5 to 2 gigabytes of RAM. Compare that to only 18% of top shooters in the US. Now, with this data, I can clearly see that more players in Brazil are using lower memory devices. So if I want to create the next Battle Royale sensation there, I probably want to spend the extra engineering effort to lower my memory min spec to 1.5 gigabytes and higher. Another big decision that has become more prevalent recently is whether to use OpenGL or Vulkan. OpenGL is widely supported and well known to game developers, but Vulkan gives more control over the GPU, which can lead to much better performance, especially for high-fidelity 3D games. Device manufacturers are continuously expanding support for Vulkan, and with reach-in devices, you can now analyze how many active devices support it in your target markets. You can also see a breakdown of which versions are supported as well. Using this data, you can make an informed decision about which rendering API makes sense for your new game. Reach-in devices also shows information about SoCs. This can be very useful in giving you guidance on what physical devices to obtain and test on. Many times, games will have issues on specific chipsets, and usually those issues are found only after the game launches, which is not ideal for you or your players. Now you can actually get a sense of what SoCs your game will likely encounter in specific regions. So for example, you can see here that these 3 SoCs have a large install base for this particular genre. So I'd want to obtain devices using these SoCs and make sure I'm testing on them regularly. Some developers are also wondering what support looks like for 32 and 64-bit. While it's really easy to support both using app bundles from a distribution standpoint, you might be considering dropping 32-bit support entirely. By looking at the ABI section, you can make a decision on whether or not this would make sense for your target markets. And as Lauren mentioned earlier, if you're part of the Google Play Partner Program, you'll also see play-wide distribution data. As you can see here, nearly every device supports 32-bit, but not all devices support 64-bit yet. So I might be making my game incompatible to a lot of potential players if I drop 32-bit support. Now, up to this point, I've been showing practical examples of how you can use reach-in devices to determine minimum device requirements for a game that has not launched yet. But all of this data is extremely useful for major post-launch updates as well. Our friends at FunPlus wanted to launch a major update to their hit game, State of Survival. This overhaul upgraded certain game features from 2D to 3D, meaning they would require more memory, more CPU, GPU, more storage, and more battery. The big challenge they faced was figuring out which devices would get the update. Because of the increased performance requirements, they risked pushing the 3D version to too many devices and causing a widespread decrease in game performance. They didn't feel they had an accurate view of all the devices their players were using, so they used reach-in devices to analyze the RAM, GPU, and OpenGL versions of the devices across their player base. This allowed them to validate their original list of which devices they calculated could handle the update and release it with more confidence. So that's a brief overview of how you can use reach-in devices to answer Minspec questions. Now let's tackle the other 2 I mentioned earlier. Where are players having issues, and how can we improve our game's reach? Both are really common questions for games that have already launched and are looking to improve upon their success. Since the Play Store uses crashes and ANRs to influence your game's discoverability, it's very important to address these issues after your game launches. Android Vitals will tell you your overall crash and ANR rate, but with reach-in devices, you can drill down and view these metrics broken out by any of the device dimensions I've talked about, including additional ones that I haven't mentioned today. So suppose I go into reach-in devices for a game that I've just launched and I want to investigate my crashes on different SoCs. On the overview page, I can see the top 3 SoCs by crash rate. The dark blue bar is my game's crash rate, and the orange is the median crash rate for a specific genre, just as before. They're plotted as a percentage on the left axis. The light blue bar indicates the number of sessions with crashes for that chipset. It's plotted as an overall number on the right axis. It takes into account not only the crash rate, but the actual number of users with that SoC. This lets you easily see which SoC is having the greatest impact on your overall crash rate, which might be different from this SoC with the single highest crash rate. So in this particular instance, I can see that the first SoC has a very high crash rate compared to other games in the same genre. And the number of sessions with this crash is pretty high as well. This is something that I should definitely investigate further, as this one SoC is a large contributing factor to my game's overall crash rate. Now in this example, I'm looking at crashes, but you can also see the same breakdown with ANRs instead. Let me show you one more interesting example. These 2 SoCs are very popular in India for a sample games genre. However, the sample games install distribution on these chipsets is much lower than its peers. This shows that there may be a great opportunity for the sample game to capture more players in India. And if they did, those players would likely be playing on these 2 SoCs. But If we look at the crash rate on these two SoCs, you can easily see that they are way above their peers' median crash rate. Essentially, the people in India who are already playing on these SoCs are seeing lots of issues compared to other games in the same genre. If the sample game was to capture a larger chunk of the market in India without lowering the crash rate first, they'd likely see poor engagement and bad user reviews. But by analyzing the data in Reach and Devices, the QA and engineering team can hopefully investigate and fix those issues before that scenario becomes a reality. Well, that's all I have for today. I hope these brief examples have given you an idea of how you can use Reach and Devices to help you determine a Minspec for your new game and help guide you in your efforts to optimize and fix issues after it launches. Now I'd like to hand it back over to Lauren, who will be talking about what's coming to Reach and Devices in the near future. Thanks.
Thanks, Ben. So you've just seen how Reach and Devices helps you make decisions around Minspec and optimization. And in Ben's examples, he used installs as a measure of opportunity, whether that's your own installs, your peers, or play-wide data if you have access. But what if your primary focus is not installs, but revenue? If you're monetizing through in-app products, then you probably don't see all installs as equal. You'll consider your paying users differently from your non-paying users, and within your paying users, you probably have different tiers of spend, with different strategies for each tier. To meet this need, we're launching revenue metrics in Reach and Devices. This means you can make decisions from a revenue perspective instead of an install perspective, if that aligns better with your business model. For example, you can answer questions like, how much of my revenue is affected by this technical issue? What's the revenue impact of changing my Minspec? What's the revenue potential of this segment? In addition to revenue metrics, you can also explore revenue growth, both rate and absolute growth. This is important if you're planning for the long term, because if you have a game that's doing well, you want to keep it relevant for as long as possible. To illustrate how you can use the new revenue metrics, I'd like to come back to FunPlus again. They're constantly updating their game, State of Survival, with new live ops events, assets, and more. With every update, they want to make sure that the game performs well on user devices, and one way they do this is by tailoring assets for different device specs. For a recent update, they were wondering if it was worth building dedicated assets for low RAM devices, or whether to compress existing assets from a high-end device. To make this decision, they looked at their revenue distribution by RAM, and they concluded it was worth continuing to invest in tailored assets for devices with low memory. There are a couple of other new features I want to call out. First, when you select your metric, you can now tweak some aspects of the calculation to suit your needs. What you can tweak depends on the metric you chose. For example, if you pick revenue, you can choose what types of revenue are included and what time period of revenue you want to aggregate over. If you select revenue growth, you can specify the period of time over which you want to calculate that growth: monthly, quarterly, yearly, and so on. I really like this feature, as it allows you to tailor this to your specific objectives and time horizons. We also show your metric configuration on the page itself, so you always know exactly what calculation you're looking at and can reconcile it to other data that you might have, whether within or outside console. In addition to editing metrics, you can now also see your install, revenue, and issue metrics broken out by device type. You can also use filters to focus on a single device type at a time. This is part of our broader efforts to help developers to build, publish, and manage their apps across different platforms aligned with Google's Better Together initiative. And of course, if you're interested in reaching players beyond mobile, you'll see that Reach and Devices allows you to understand and plan for Google Play games on PC, which you may have heard announced today. While we're on the topic of revenue growth, I want to call out a related launch for developers who monetize with IAP. This launch enables you to evaluate how well your game is monetizing and see opportunities to grow your revenue. Prior to today, this insight was often hard and costly to obtain, and not every developer has access to the resources and expertise required. Strategic Guidance codifies the best practices from Play's own growth consulting team in an intuitive new interface. It makes it easy for you to understand the drivers of your top-line IAP revenue and the relationships between them. Just like Reach and Devices, it offers peer benchmarks, country-level data, and trends over time. And it also includes actionable recommendations for capturing the monetization opportunities that you see. And all this is available in the console now. You can think of strategic guidance as a tool to understand the business levers for growing your revenue. Reach and Devices gives you insight into the technical levers for driving revenue. So used together, they provide a holistic picture of your IAP revenue drivers. Okay, now we've spent some time on Reach and Devices, demonstrated some applications, and introduced the revenue metrics. Now let me turn to Android Vitals, which is used by nearly 70% of our top 1,000 developers for technical troubleshooting. Android Vitals is your source for monitoring your crash and ANR rates. It also gives you the underlying issues that drive those rates, so when you need to take action, you can drill into the crash and ANR clusters and individual stack traces. One of our top feature requests is the ability to explore Vitals metrics at country level. If your game is available in multiple locations and you have different strategies or game experiences by market, then understanding metrics at country level is important both for troubleshooting and for prioritizing. Today, we're delighted to announce that country data is now available in Vitals, both as a breakdown for each individual metric and also as a filter. This feature also carries over into Reach and Devices, allowing you to see country views of crash or ANR rates alongside your install and revenue metrics. Another long-standing and even more common developer request is to be able to access Android Vitals beyond Play Console. In fact, this is probably the #1 developer request we've had in recent years. And today, you are the first to hear that the new Developer Reporting API is in general availability. With this API, you get programmatic access to all 4 core Vitals metrics and issues data. This includes crash and ANR rates, counts, clusters, and stack traces. If you want to automate your quality workflows, work with Vitals data alongside other datasets, or build your own dashboards, the reporting API is how you can do it. The API includes the new country-level data, and it even gives you access to historical data going back 3 years. To get started, check out the documentation at the link on the screen. I've talked about stability. What about performance? Well, today the rendering metrics in Vitals only measure Android UI Toolkit rendering. They don't cover frames that are rendered with OpenGL or Vulkan. In other words, they don't include your gameplay. To make things clearer for you, we've renamed and reordered the performance metrics on the Vitals overview page. Now you can see very clearly when the existing metrics don't cover gameplay. But what if you want gameplay metrics? Well, that's why we launched Android Performance Tuner in 2020. APT measures not only gameplay frame rate metrics, but also fidelity and loading time. So we recommend that you use it alongside Vitals to validate and refine your device targeting decisions if performance is a consideration for your game. And keep in mind, you can do this not only once you reach full launch, but even in the run-up. I want to call out a recent developer success story where the developer did exactly this. Spocko, the developer of The Witcher, used APT to assess their game's performance on different devices with real testers during soft launch. Based on this data, they refined their device targeting to launch with confidence on a wider variety of devices, which resulted in both more device reach and 10% more downloads. You can read more about how they did this in the case study on our APT site. Of course, every developer's experience will be different. So we've covered a lot today. Reach and Devices best practices and new features, Vitals country filters and API access, and new APT case studies. Whatever stage of development your game is at, and whatever your quality focus, I hope there's something in this talk for you. Check out the links to start working with these new features and do keep your feedback coming. I know some of these launches have been a while in the making, but as you can see, we really are listening. Thanks again.